if we're talking about UAP, Office of Director of National Intelligence a couple of years ago published the definitive paper, UFOs are real, pose a threat to flight safety, right? So that's our starting point for UAP. I mean, there's all this other stuff out there, but they're real. And then we have, the 5 observables, and those seem to characterize what, like Jack Sarfati and others are calling warp drive propulsion. So from a physics perspective, that would be a place to start. Like, are UFOs, do you think that they're bending time-space? Do you think they're bending gravity?
I mean, it's possible. I think there could be a couple different technologies being used. I mean, it might make sense that for interstellar travel, you might want one type of technology, but once you get close to a planet and you want to come down, then you might want to use different technology. I don't know. I'm not sure, right? Because you have vacuum versus the atmosphere, so that's a difference. And then it's weird how some of these craft apparently seem to either disappear sometimes, or maybe it almost looks like a ball of light. I mean, there's so many different claimed craft out there. So some people are claiming they're interdimensional. We don't know what that physics would be yet. Is it actually just really intelligent cloaking by making electromagnetic waves bend around it? Or is it actually doing something fundamental at the level of space-time? We don't really know. I mean, we have this observational data, but everything we see is with light. So that can be an illusion within itself as well. It's harder to really understand if it's gravitational just with our eyes.
Well, the reason I asked that was, so Thor, who was Thorsten, a German fellow, who was with the SCU, he did a paper. It was called UAPtheory.com. It was a paper that he put on a website. And when he was looking at the Agua-Dia video in 2013, there are ripples, especially when it changes path, and it looked like people have described shape-shifting for a long time, but what he thought was that it was gravitational lensing. And when I looked at that, I was like, yeah, I could see that, which to me would make sense if you're doing some kind of a gravitational shell effect, then it would seem like that might refract light. But
yeah, I know that there was this whistleblower, Mike Herrera, who claimed that he saw this craft that just lifted up at incredible speeds, but none of the trees shook. Okay. It was as if there was no wind. So that's pretty puzzling to think about how you would do that without gravitational manipulation, right? Because you would expect that if you're just propelling in some way, let's just say it's electromagnetic, you have some clever way to do it without oil, you would still think that that motion is going to hit the air and move the air and make the leaves around, especially if you're moving at an incredible speed. So if that claim is true, then maybe it does suggest there's something gravitational going on. Also, these hairpin turns, right? If there was a being inside, we don't know, are these drones or are there actual biologicals on board, right? Some are claiming that they've recovered biologicals, right? So if that's true and they're in the craft and they're going at these incredible speeds, you would think that you would want a gravitational effect in order to do those hairpin turns without having crazy acceleration from the G-forces, right? Pilots can only go so fast before they start getting nauseous. So if you did the gravitational manipulation, pulled that off, that would have a lot of benefits. So if it's possible, humanity or other life out there would explore those ideas and try to turn it into technology.
Yeah, and that would, in a way, that would almost make sense. I mean, the kind of turns they did, I think when the UAP and the Nimitz encounter, if I remember correctly, they set off the ICBM detector for inbound space objects, right? And then they descended rapidly to almost sea level. And so that was where Kevin Newth estimated something like up to 50 G of acceleration. That would destroy, there's no airframe, right? People talk about black projects. Could it be some kind of a super stealth aircraft or something like that? There's no human built airframe that could withstand that. And when you think about it, the occupant inside of something like that would just be liquefied, right?
Yeah.
So, that's another aspect of it. And so that Arrow report that came out, they alluded to black projects, which could explain lights in the sky, but it wouldn't explain that kind of performance.
Yeah, it's definitely curious. There's a lot of interesting stuff out there that people have claimed to see, so
yeah,
it's hard to know what needs to be done to kind of figure it out at the next level, right? There's so many mysteries.
Well, so what do you think about this, the whisper of interdimensional hypothesis?
I think it's a little unnecessary, but it could also just be a way to visualize wormholes.
Okay.
Maybe that's one way to think of it. I mean, if you just think about having a wormhole where it's just like teleporting you from one location to other, you could think of it as being some non-local process where I'm just here and then bloop, now I'm here. Or you could say, well, maybe there's this wormhole going into an extra dimension that we just don't see it because we can't perceive it, right? And then, so that could be a local process that just leads it. And the thing I think about is I wonder if there's even a way to determine what it is. I guess it would depend on what the experience is like for the person who's traveling. I wonder if they just feel like they're tunneling from A to B without just non-locally traveling, or do they feel this notion of moving continuously through some space? I don't know.
Yeah, so one would be like Stargate, where you step through it. On side A, you're on planet X, and side B, you're on Earth. And then the other one would be like Jodie Foster Contact, right, where she's inside the throat of the wormhole, going through it, and special effects and all that stuff.
Yeah, right. Well, even with Stargate, right, as they went in, it was like, they had this kind of all this effects of going on. They're in some realm, right? And if it's some realm where we can't even see things clearly, and it's going to be hard to do experiments in that realm, let's just say we figured out how to make one of those things, then let's say we send some probes through to try to measure stuff and everything is haywire when it's in that state. It's going to be hard to even identify, are we in some non-local realm that's just different?
Okay.
Or is it actually like an extra dimension? And then you could explore both possibilities and then ask the question, is there even a mathematical difference? I don't know. It depends on how it's set up, but I could see it going either way.
Yeah. Well, so in a way, almost what you're alluding to is it may be a moot point. And so I did an interview with Julia Mossbridge. And one of the things that she had said to me was, when you're thinking about the spans of time and distance that are involved with this kind of stuff, she's like, your normal thinking doesn't apply, even if it is normal processes, right? And so, like, that reminds me of what you're saying. It's like, is it another dimension or is it our dimension? If it's a far enough distance apart, it really doesn't matter, right? So,
yeah, and we always have our intuition just from our surroundings and what we've learned, but sometimes you can have two different sets of intuition that lead to the same explanation, right? I mean, it's at the end of the day, it's just moving from A to B, right? Someone could argue about, no, I do it this way, no, it's actually this, but you could develop technologies with both of those two intuitions. Maybe it turns out they're the exact same technology, but there could be two ways to describe it. I mean, it's almost like interpretations of quantum mechanics. At the end of the day, it just depends on the data of what you're doing and how it gets interpreted. So,
well,
something to keep in mind. But
what do you think as a physicist? I mean, like, do you think that these are some kind of extraterrestrial or some, non-human, right? NHI, non-human intelligence. Do you think that these are some kind of NHI craft, vehicle, something along those lines? Or is this...
My gut tells me that there's both. I think that there's human-made craft and probably non-human craft out there. I guess I could see the motivation why ETs would be interested in military bases. There's talks that they've interfered with nuclear bases in the past, as if some people have claimed that when we started experimenting with nukes, that, well, there's kind of two aspects. Either there's some people have claimed there's aliens underground, and then it's like, well, are they even ETs if they've been here all along? That's one perspective. And then other people claim, oh, well, maybe these nuclear bombs that are going off are affecting, if everything's connected, then it's affecting the extra dimensions in ways that we can't even understand. So then they're coming from so it's like, I don't know, there could be beings underground, there could be beings in extra dimensions. I mean, we can't really rule out anything.
Yeah.
I mean, I know that Richard Doty claimed that there was essentially some facility underground and he saw this being that was non-human, and then he claimed that the US attacked it and blew it up, and then this other military facility got blown up. I don't know, but then it's hard to know, right? He's one of these characters who put out all this information back in the day, then said, oh, it's a lot of disinformation, and then he comes out another decade later and says, oh, well, most of it's true. And so it's really hard to get to the bottom of what is actually, what's the real data, what is actually true.
Well, and yeah,
A lot of claims.
One of the things you're touching on is this cultural aspect of it, and that's a real challenge because, I mean, we've got 75 years of basically cultural mythology, and it could be a mixture of true and false, and we just don't know which, right? And and so like you've got movie plots like Close Encounters of the Third Kind wrapped up with it, but then was Close Encounters, people have said, well, Spielberg was actually influenced to portray a real event, and so is it a fictionalization of a real event that is then presented to the public, and it's all kind of mixed up there. So Betty and Barney Hill, which is one of the big first abduction encounters in, I think, the 1960s, if I remember correctly, they saw reptilians. That's where this reptilian idea came from. But now there is speculation that the Star Trek episode where Kirk punches out the reptilian aired I think it was 3 weeks before that, right? And so people have said, look, maybe this was just subconsciously what they, this was it was in their mind. Something happened, who knows? But that doesn't necessarily mean there was a reptilian. That was just kind of the closest thing they were able to grab mentally,
Yeah, I mean, sometimes I think about it. If I were a conscious dinosaur and a world cataclysm hit, I would probably start digging.
Well, there you go. Yeah.
I don't know.
I like this idea of UAP being, for me, that's really this connection between the ocean and UAP is really interesting for me, and there are a couple of reasons for it. One of them is there's this long history of tales, but when you look at the cultural mythology, the stuff that we know has been influenced by fiction, it's all on land, right? It's like Roswell, Area 51, Independence Day, all those kind of things. This idea of UAP being out at sea, living in the ocean or something like that, that is not that common. And yet when you see all this evidence come forward, it's like, well, wait a minute, maybe there's more legitimacy to that data, And then there are other points that, for me, that are just kind of interesting. I did an interview with Jay Storrs Hall, and he had a book called Where's My Flying Car, where he talked about nanotech being able to being able to pull materials out of seawater. And he made a really important point, which was, if you want to build a base or self-replicate probes or, anything along those lines, build UFOs, if you're an advanced species, you still have to mine those materials.
Right.
Unless you're in the ocean, you can just pull it out of seawater because it's all there.
Yeah, there's a lot of minerals. So if we could get to the point where we could just reassemble atoms arbitrarily.
Yeah.
Right. I mean, that's kind of the Star Trek dream. Atomic assembler, essentially. If you had that technology, then you could start making materials in much more different ways where you don't need to mine the pure elements. You can just grab some water and extract it that way.
Yeah.
And you might need a lot of water, but fortunately there's a lot of seawater, and we know there's a lot of minerals, and it's curious how there's different mineral content in different areas around the earth.
Yeah, so it is interesting. They could pull nuclear materials out too if they're nuclear powered, right? If that's their power supply or something along those lines, So that was an intriguing thing. But yeah, the UAP thing, I mean, I don't have any. I feel like the more that I hear about it, the less definitive information there is, right? So
yeah, I mean, it seems that, let's just assume that there are people who know more information about it than others. If you could get access to a fraction of that advanced technology, why would you want to release it to the public? Wouldn't you want to, if you're the military industrial complex, let's just say you're contracting for the government and you have some advanced technology, I mean, that gives you an upper edge. So it seems quite logical that you would want to kind of confuse the public just so no one can ever figure it out, and then you just hold on to that information.
Yeah, well, unless they're confused themselves. I mean, again, the Chinese spy balloon thing comes back. It's like, how do you miss something like that? It's like the size. It's got a payload bay the size of 2 school buses, and it's floating over the U.S. and didn't know it was there.
Yeah, and that's the other thing. Everything's so compartmentalized. It's easy when we're talking about these things. You just say the government, the military, but it's not as if it's a sole entity or personality. It's a very complex organization. Organizations we're talking about. So maybe 99.9% of the entire military has no idea and is all confused, but maybe there's some compartmentalized project within another project where they have a bunch of information, and maybe there's another compartmentalized project in another direction that has different information that's partially overlapping, and are they even talking?
Yeah, it's. I mean, his name is escaping me right now, but I did an interview with a fellow who, he basically did a research lookup in the top secret Air Force archives. He worked in that facility. He had the clearance. He had the need to know, all that kind of stuff. And so he said, you know what, I'm really interested in UFOs. And we did an interview last year, and he had, I think, a year or two in this post to be able to do this. And so he went through all of these files, and he got to see all the stuff that was redacted, right? And his takeaway from it was, he was like, 99.9% of the stuff is already out there. It's just like names and dates that are crossed out, basically. That was what he came back with. So now that does not mean like that it's not in some other archive. There are lots of them out there, but in terms of the Air Force archives, he said there's nothing really new or novel that hasn't already been put out there by FOIA already. So.
Yeah, and then the government contractors is another aspect. It's easy to get confused between, say, Boeing and the military, and it makes sense that there's a lot of reasons why you want to bring information out of government into the private sector. So then that's one of the interesting things. I mean, with these hearings, it seems like they're claiming they'll be able to access some of this information even in private companies, but I don't know how that'll end up working.
Yeah.
But we'll see. We'll see if we hear anything.
Yeah, that will be interesting. Well, and I mean, they have other priorities too, right? I mean, other than UAP, like the major defense contractors, I think they have to start working on autonomy and drones, right? And they already have. Those are big areas for them. But like that drone replicator program and being able to harness some of this AI technology, I think those are kind of big areas that are redirecting their attention. So UFOs are probably more of an annoyance to them than anything else at this point.
Yeah. And at some point it seems like there will be mass confusion for a while. So I really appreciate something that Jeremy Reese points out, where really at the end of the day, it's up to the scientists to figure this out. And the great thing is that humans are capable of amazing things. So if we get enough scientists who start looking at this, and we don't have to get all of the data released, we can just reverse engineer with our minds. We don't need to literally see these crafts. We can just explore physics at a deeper level, try to understand, okay, how does electromagnetism relate to gravity?
Well, okay, so that takes us to gravity, which you wanted to talk about earlier. That takes us to some of this physics. But so yeah, if we use UAP as a tool to understand, right, we don't necessarily know exactly what's going on, but if we could ballpark it, do you think, I mean, because like I know you're familiar with the Alkebeer warp drive, I know, and then you've looked at Jack Sarfati's metamaterials, and you've probably seen a couple of dozen other ideas. Is that something where you're able to start to ballpark that and hone in on, okay, this is how we might be able to build one of these?
I mean, I don't have exact specifics yet. It's clear that there are solutions. I mean, the main thing is, I'll say I don't see a concrete way with the resources and money we have to create it within 5 years. I don't see that path, but I'm very hopeful that there's a wide window of exploration. And I mean, I'm a little biased since I'm a theoretical physicist, but I think it makes sense to continue investing in exploring theoretical physics and then try to understand the fundamental laws of nature at a deeper level. I just always had this intuition that if we could figure out unified field theory, there should be some technological application of that.
Okay.
Right?
So
at
it's
some
the coupling.
point.
It's understanding the coupling, and once you've got that, you can modify it.
I mean, that seems to be the idea, right? It doesn't seem like we're just going to use gravity to induce these gravitational effects. I mean, obviously, you want to look at the gravitational theory, but it seems like you would want to power these devices electromagnetically to start, and then have that electromagnetic effect somehow influence the gravitational field. So that can be studied, but we have a great understanding of quantum electrodynamics, but even studying the classical theory, I think there's a lot of progress that could just be made without even unifying the forces, just studying what we know about gravity today, what we know about electrodynamics today, just exploring it at a deeper level, looking at more coupled solutions.
Yeah, well, that makes sense, and this is like a multifaceted like issue, because then you've got like energy supplies and energy storage, and how do you power these things? How much power would they potentially require?
Hmm.
And like going back to what you said about this, the transmedium travel and the speeds. How do you solve hull ablation? Right? I mean, there are so many different aspects to this.
Yeah, there's a lot of problems that need to be solved, and it might not take the most logical path, but at first we had this idea with the Alcubierre drive, you needed negative energy and a ton of it. And now in the past few years, there's still debate and a lot of controversy, but there are claims at least that maybe you could actually do it with positive energy, and maybe we don't actually understand energy at the deepest level yet, but that we would still need a ton of energy, right? So that's just one step closer, right? Then how do you make it more efficient? Is there some effect, some enhancement? I mean, that's what Jack Sarfati is attempting to do.
Yeah.
We'll see if that works out. But once you could get it from positive energy, then you have to figure out, well, how can I do it with a reasonable amount of positive energy? And then once that's figured out, it's, well, how can I do that with a reasonable amount of energy and actually afford it, right? So the other exciting thing is that we do have AI coming on board. So there's certainly going to be certainly over the next century, there's going to be a radical way that we even think about making things, fabricating things. Once we get robots who have better science knowledge, maybe not even the fundamental physics, but just like the encyclopedia of all the engineering tables, and they can just be this robot that can make some CAD thing to 3D print it and then put it all together. That's going to allow for a much more affordable way to explore materials. And right now it might seem like, oh, we need trillions of dollars to even attempt these things, and it's not clear if it works. But what if we go 15 years in the future and now it's much easier to make things? Maybe that opens up doors that are just difficult for us to understand right now.
Yeah, no, that makes sense. Well, and like with what Jack is talking about, so he's looking at the metamaterials, right? And and then other folks have looked at these UAP supposed skin samples, hull samples, right, which are layered materials. And so it's interesting to see that convergence, right? It's like, because if I understand correctly, his thing is the speed of light changes in materials. And so then, therefore, you can start to manipulate time-space a little bit more easily than you can in just free space.
Yeah, that's what he's going for. Basically, there's this 8 pi g over c to the fourth, and so he's trying to essentially mess with that c to the fourth, the speed of light, to get an effect. I think he has to push a little further with the mathematical details and maybe figure out if that interpretation does make sense. Sometimes I can tell he's trying to be uncontroversial as possible. He's trying to say, I'm just doing general relativity, but when I looked at it in further detail, I'm starting to think that maybe he would need to almost have an ether or something to get that, because just because you have the speed of light, it's really the speed of massless particles from just a relativistic mentality. It's just that light was the first example of a particle that had no mass that we understood, so we call it the speed of light. But we know there's speed of gravitational waves, speed of gravitons. I kind of look at gravitons as being gravitational waves. And so if we have those particles, we kind of understand that dielectric materials interact with light differently than gravity. So I'm not necessarily convinced that the speed of gravitational waves in materials has to match the speed of light in materials.
Okay, I see what you mean.
But it's certainly an interesting question, right? Because what I like about Jack is he's asking that question, what would be the physics of gravity inside of matter? So I think that's an example of an idea that can be explored further theoretically. There could be some debates on that, maybe a few different ideas, and then eventually it would be tricky to figure out how to test that, but maybe if different theories might suggest different ideas to test in the lab, and then those things could be tested.
Yeah, well, so some folks have suggested that layered skin might be some kind of a waveguide also, right? And so maybe there's some kind of a resonance. This goes back to what Mark is working with.
Yeah.
This whole idea of resonant frequencies that might interact with gravity or something along those lines.
Yeah,
So,
and it's very interesting that as physicists we get a little pessimistic. We almost think that everything's damped. It's very hard to. There's always going to be resistance somewhere, but now we're entering this interesting era where we have superconductors at cold temperatures. We're pursuing plasma physics at high temperatures, and so it's clear that you can do pretty crazy things. You can have plasma devices that create, and we know the sun creates energy in magical ways, let's say, and we know that superconductors could lead to magical technology, but there's still this perception in the physicists that nothing good can happen at room temperature, right? It's only when it's cold, it's only when it's hot, but there has to be something at our temperature that's possible that we haven't figured out yet. There's been more and more excitement over these high temperature superconductors, and when they say high temperature, they just mean room temperature is high, relative to those very cold temperatures. So there's a lot of advancements that are happening in that direction. I think eventually we're going to have a fundamental paradigm shift about how efficient energy can be used, and I think that will change our perspective on what everyone thinks is possible.
Okay.
And then once that happens, also what you're saying with resonance, it's a very interesting thing, just because when you hit something at its resonant frequency, if there is no damping, the response just explodes to infinity. And so the conventional approach is always, well, there's always going to be damping somewhere. So you can still get a really intense response, but it's going to be finite. But then the other puzzling thing is that in quantum field theory, all of these quantum fields are based off these simple harmonic oscillators without any damping. So it's always puzzled me, maybe not always, but it's puzzling how physicists, you would think that they would want to dampen that, maybe, right? Because there's never any free lunch. Thermodynamics, classical thermodynamics, second law makes it seem like there's no way you should get such a response. But if there actually are these perfect oscillators in the vacuum, and we could figure out how to get some complex interactions with that, maybe could we resonate with the vacuum and do some incredible things? I mean, that's an interesting idea. And it's curious how Todd Desiato, he actually thinks that gravity is the damping of those fields.
Oh, there you go.
So maybe
a lot of that's paradigms,
but still, either
right?
whether it is dampening or not, certainly resonance can cause incredible gains on systems when you get things into resonance. So there's definitely, resonance is definitely probably going to be very important for the picture one way or another.
Yeah, it's intriguing. You had other stuff too you wanted to talk about.
Sure, why not?
Okay. So you had a diatribe. What was here, I'll flip the camera around.
Yeah, so we've been talking about electromagnetism a bit earlier, but obviously gravity is going to be another key piece, and I think something that's going to be really helpful is looking at the analogy between space-time and materials. So there's all of this differential geometry that's used in gravity to describe how space-time works, and there's this term called metric engineering.
Yeah.
Can we engineer the metric of space-time? If we could do that, then that's how we could get all of this warp drive. We could do whatever we want, manipulate gravity itself, manipulate space-time, this metric engineering. So we have engineers out there who are building stuff in the real world with materials. So I'm not saying that we literally can do this now, but I think it's helpful to at least theoretically consider possible how could we engineer space-time? How can we create space-time at the most granular level? We want to get the most precise control. And so when you start studying the differential geometry, in Einstein's theory, there's curvature, and that is actually the most coarse, the largest scale form of gravitation that you can have. So in that sense, it's somewhat crude. If you can only access the curvature, those provide defects to space-time. And so you can think of space-time as a crystal, and the defects to that crystal can be gravitation itself. And you have these atoms of space-time, just like materials are made up of atoms. And then if we want to get back to continuous GR with continuous space-time, we can just say that these atoms of space-time are infinitesimal. So they're really close together. We can't really perceive them, but we can still, in our minds, play this game of, well, how could we manipulate these atoms one atom at a time, rather than doing a larger defect? So as we were talking about before, there's torsion that Elie Cartan introduced, and those introduce smaller line defects, but it's still not the smallest one. The smallest one corresponds to non-metricity, which is literally removing or adding a single atom of space-time. But once again, there's no evidence for non-metricity. I mean, there's no evidence for torsion. That is a controversial topic. This non-metricity, no one talks about it. I mean, some people do. It's actually been it's been explored in a lot more detail in the past 10 years. I would say relatively the amount of research in the past decade has been exploding, which I find very exciting.
Yeah.
But still, a lot more work needs to be done, and there isn't even much work out there discussing the deepest geometrical interpretation in terms of this defect picture, which I think helps make it a lot more intuitive. For instance, in general relativity, there's all these claimed problems with singularities, right? Einstein was puzzled. He didn't like the fact that there was this black hole solution because it implied that there's a singularity.
Okay.
And what that means typically mathematically is it's a point where basically the math breaks down, everything explodes, and typically what you say mathematically is that the theory just doesn't apply there.
Yeah.
You don't know. But general relativity has gotten so popular that a lot of physicists have started to embrace it, where, well, maybe these singularities are real, right? And so this kind of leads to a debate between mathematicians and physicists, let's say at a high level. And what really blew my mind is once I realized that there is a geometry for removing a point from space-time. I mean, that sounds to me exactly like what you would want to create a singularity. If you just remove that point from space-time, mathematically it doesn't exist. You can't even talk about it. So you could have everything where everything's ramping up where it's approaching that singular point, but then there's just a little defect there, and it's not really possible to describe that.
So in a singularity then, a singularity would be to kind of bring this back, because you're looking at it from this crystal defect model, but to bring this back to our model, it would almost be like a black hole is a point in space and time that is not in our space and time.
Yeah, that's another way you could look at it. I mean, you could think it's like, I remove this point. You could play a game. Can you just remove points, or do you have to, is there a conservation of this fabric? You know, then we could just say, oh, there's this other piece of fabric over here, and I moved it from here to there, and we don't have access to that fabric, right? So that's kind of an example. Are there these extra dimensions where we can, you know, we have to have some conservation, we have to move it over there, or is it just not exist at all and we have the freedom to remove it? It's kind of the same thing at the end of the day. At the end of the day, what we can observe physically is the point got removed.
Yeah.
Assuming we could even observe that.
No, that's intriguing. That's intriguing.
Yeah, so once I realized that the non-metricity is really the most microscopic form of gravitation, if you're trying to do metric engineering, then it seems like we would want to rewrite all of general relativity in the language of non-metricity, just so we can have the mathematical ability to even refer to these granular defects in a precise way, right? The curvature, it's always taking out these wedges of space-time. And so it's imagine you were trying to do origami. Well, origami you only fold, but let's say you could cut the pages. Let's say you were less interested in the folding, but you wanted to make some elegant origami that allowed for cuts.
Okay.
But imagine you had these weird scissors that only allowed you to take out huge wedges.
Yeah.
It would be very, from an engineering perspective, it would be very inconvenient. You wouldn't be able to make everything with as much specificity as you'd like. And there's also this energy problem, right? We want to figure out how to get this warp drive with as little energy as required. If our tools are requiring us to always cut out a wedge, which takes a lot of energy, what if there's this surgical needle, right? I could just take a needle and poke it through the piece of paper.
Okay.
How can I do that if I can't even do that if all I can do is take out wedges, right? And so you can imagine it probably takes a lot less energy to poke a needle through the paper than it would to cut out a wedge.
Yeah.
And now we're changing the topology of space-time itself. And if we want to, let's say we want to create a wormhole. I mean, just very simply, let's say we have a point here, a point there. Can we just remove a point from space-time, remove another point over here, and then create a line in between that? right? If we're cutting out wedges, we can't cut lines. Like normal scissors, you can just cut a line, right? So now, rather than cutting out wedges, I'm trying to say, can we just have something where you can have needles and scissors and also glue? So you can cut it in arbitrary ways and glue it in arbitrary ways. Once you start to look at it from that perspective, you can almost just 3D print space-time, I mean, conceptually.
Well, so does this connect back to the ER equals EPR conjecture? And the reason I ask is that's like Jack has started talking about that a lot, right? And then Maldaceta and I can't remember who the other scientist was, but
Maybe Susskind.
Susskind and Maldaceta, it was their conjecture. But if I understand correctly, what they're saying is that a black hole and a wormhole are more or less the same thing, right?
That's really interesting. So it's about entanglement and wormholes. So that is a very interesting question. I'm glad that you asked that because I didn't even think about it. So yeah, there's now this holography. There's this ADS CFT holography. One of the other possibilities, a lot of people are starting to realize, maybe space-time itself is emergent. And one of those possibilities is that you have these entangled fields, and then you can have these emergent fields that emerge from that, and then maybe space-time is working with those emergent fields. So for all we know, there could be kind of this deeper space-time that is related to those entangled things.
Okay.
And this isn't even really directly related to the wormholes. I mean, maybe it is, but I think that's an interesting perspective as well, because this relates to quantum gravity. So that's another approach. Maybe we can kind of understand that space-time isn't even what we thought it was. Maybe there's some deeper level of reality that we're not even perceiving.
Well, there's the Michael, and he didn't come up with this, but the Michael Talbot book, right? And the holographic universe, I think it was. And he was talking about Aronoff Bohm. But, but I think the way that he expressed it, and a lot of people have read that book, I think that stuck with a lot of people. It stuck with me. He was, he was saying that, it's kind of like flatland versus three-dimensional. He's like, the reality may be flatland, and it would be nothing that we could visualize, right? But then, the way that we would see it comes out to the universe that we know. But you can't necessarily apply how those particles work in some ways.
Right. So to kind of bring it back to wormholes, maybe there's this network of entanglement that's connecting everything secretly, and space-time is emerging from that. So maybe if we're trying to create a wormhole, maybe when we get into that realm where we're kind of tunneling from here to there, maybe we're in that deeper reality.
And that might, maybe if it's a network of entanglement, maybe that would be the crystal defects right there, right? Maybe that could explain that.
Well, that could be a separate, you could actually have, there's this simple network that you can have, well, it's somewhat simple, where you can have this crystal in hyperbolic space. Like an Escher painting, he uses this hyperbolic geometry where it looks kind of weird. And like there's this example where you have pentagonal tiling.
Okay.
Like if you put 3 pentagons together and you try to match them at a vertex, they won't quite meet. And if you put a 4th one there, they would overlap. But if you had this hyperbolic geometry, you could actually fit 4 pentagons where they're all meeting at a corner, just as in Euclidean geometry, you can have 4 squares their corners can meet at a point, like the 4 corners, like in the US with Colorado, Utah, and all that. Imagine a different geometry where rather than 4 squares, you had 4 pentagons. In that type of space, if you put just qubits or just quantum spins on all the vertices, and all of those spins are maximally entangled on that crystal, then that leads to these emergent qubits that are logical, that don't even physically exist.
Oh, okay.
So, and that's kind of language right now, as they say they'll have these physical qubits and then these emergent logical qubits. And so right now the idea is that can lead to quantum error correcting codes. And so the way I've been thinking about it is let's flip it around. Maybe the emergent logical qubits is what we currently think is physical, right? And so there's this deeper level of what's truly physical.
Yeah, I see what you mean.
Then out of that, there emerges this quantum information that to the true God, let's say, is just logical. It's not even physical, but to us it seems physical. And then the curious thing about that is that there's all these error correcting properties. So sometimes I think of it as maybe space-time is expanding and it's happening, and then along the way these defects might get introduced, but the system has to retain self-consistency. So maybe having the ability to have these error-correcting algorithms can kind of retain the self-consistency of reality as it's kind of expanding, yet still emerging in this bizarre way.
So maybe error correction is an emergent property. Because the alternative to that, I did read a paper by a physicist who was speculating that maybe that meant we were living in a simulation, right? He was like,
right.
But I mean, even in his case, I got the impression that he didn't want to dig too far down that rabbit hole.
Yeah, so I mean, this idea has been studied in string theory as well, and it's been brought out of string theory with this ADS-CFT, and that hyperbolic tiling that I was talking about, that's a discrete analog of the ADS-CFT, so it's kind of inspiring because it has applications for quantum computing, but also quantum gravity. And then from there, we know that basically, let's see, I lost my train of thought a little bit. I was going somewhere good with that, but let's see. Wait, what were you saying actually?
Oh, I was going to the whole simulation hypothesis.
Right. Okay.
Right?
Simulation.
When you get into,
exactly.
When you get into really complex geometries of space-time, and you start to get into stuff like error-correcting properties of space-time and stuff, right? I mean,
right.
What I remember reading was, even the person who wrote that he's like, this is starting to look a little fishy. You know, that was kind of the vibe.
Right. So then we have this ADS-CFT correspondence where the idea is you have this bulk and then this boundary, and maybe we're in the bulk, maybe we're in the boundary. There's a lot of different ideas. You can explore it in different ways, but one idea is we're in the bulk, and actually on the boundary there's all this holographically encoded information where that's where everything's entangled, and then the bulk emerges from that.
That's like Hawking, right? Didn't he say that on the surface of black holes all the information would be on a boundary?
Yeah, that was inspirational, definitely. Yeah, so he had the black hole entropy, and then led to things by Bekenstein and even Verlinde, and then the string theorist Dr. Gates has talked about these error correcting codes in string theory. It's all the same concept, they're all related. So that could relate to this idea that we're in a simulation, right? What we perceive as reality emerged from something else, just as what a video game, an NPC in a video game, his reality is actually emerging from these ones and zeros in a computer, right?
Oh, so, but that's interesting though. You're actually changing that paradigm. So it could be that we're in a simulation, but the simulation may be natural in origin. Because when people think simulation, it's like the Matrix. Maybe it's not the Matrix. Maybe it's a natural matrix that just exists that way.
So there's this simulation hypothesis idea that maybe if we can create advanced video games that look like real, then maybe we're in a video game. And it kind of turns in this turtles all the way down thing to some degree, because then it's like, well, maybe that reality is also in a simulation, and it just starts to feel really silly. So one idea that Clee Irwin had, and we did this paper together with Marcelo Amaral, was the self-simulation hypothesis, which was this idea where everything, like the hardware and the software and the code, was all one entity. Like typically when we think of computers, like someone needs to build the hardware, someone needs to write the software, someone needs to power it. But what if this abstract network of everything being interconnected has the ability to rewrite itself and program itself and is the hardware, and then from there life emerges? So it's obviously if reality is a simulation, it's probably not exactly like our computer simulations. At the end of the day, language often uses analogies. So that's what leads to all this great discussion and debate, because there's many ways to interpret that analogy. Maybe it is literally like the Matrix, but maybe it's more of an abstract analogy where it's just that there's this deeper level of reality and then something else emerges from that. And maybe it's a little more subtle. It's not literally like in a video game, but kind of is.
Yeah. Oh, sorry.
There you
I
go.
guess he's wandering off. Oh, I guess it's lunchtime. You want to get lunch or?
Let's do it. Yeah.
Okay.
That was cool.
Yeah.